I now recognize Ranking Member Marshall for 5 minutes, who we have missed. Mr. Lucas, you are recognized for 5 minutes.
Thank you, Mr. Chairman. I appreciate the opportunity, and Dr. Jacobs, you've been before the panels enough times to know that occasionally we ask about the same thing, we just come at it from slightly different angles. And with that in mind and in spirit, I'd like to note that I'm concerned that NOAA may be approaching EPIC implementation as something of a software issue, where the agency views the biggest challenge to improving weather forecasting as simply improving existing software. What assurance can you give the committee that NOAA is engaging the academic community and the private sector to ensure that this is truly a community-based weather prediction model?
Well, the primary assurance I can give you is that it'll have to exist outside of NOAA. And having the involvement of industry and academia is essential. This will all be built into the request for proposals. We had a big meeting in August. We just released the report of that meeting yesterday. And we had a lot of stakeholders from all the sectors involved in contributing. So this is the whole point and design of this is a stakeholder-run program with an operational outcome that NOAA should benefit from.
Along that line, Doc, I'm a member of a body where there seems to be an ever-increasing turnover. So when I ask this in the politest of terms. What assurance can you give the committee that EPIC will continue past your tenure at NOAA?
Well, once the RFP, once it's...
And I'm not predicting the length of anyone's tenure. I'm just asking about continuality.
No, this was a top priority for me, and making sure this lives past my tenure is extremely important. And that's another reason why having it, externally managed would ensure that if it's inside of NOAA, then NOAA, has complete and total direction. If it's external, I expect that NOAA will have a seat at the table in guiding what it does, but largely driven by external stakeholders will ensure that even if I'm not at NOAA anymore, it will still be successful.
And along that line, let's, if you could expand a little bit on your current acquisition strategy and the timeline that we're very concerned about here about implementing EPIC.
So there's the RFP, which we expect to go out early next year, first month or two, and then an additional. So there's two sort of acquisition strategies we're concerned about. One of them is where does EPIC live? That will be, we'll learn that when the award goes out. Then there's the acquisition of cloud-based compute resources. This is a little bit trickier. So we have a need to procure cloud-based resources, but right now with the federal acquisition regulations, it's very complicated for us to try to figure out how to buy cloud compute on a demand that fluctuates. It's not just like buying a rack of servers.
And as an elected official, I would be remiss if I didn't ask how universities such as Oklahoma, the University of Oklahoma, would have a chance to participate in EPIC.
Well, my hope...
There are homegrown questions, wherever we come from.
So obviously their expertise is largely in convective weather forecasting, and there's a component of this that will deal with that weather forecasting. I would hope that they would be both contributing model improvements as well as benefiting from some model improvements, as well as the Mesonet program and all of the different observing systems. We'll be able to test those in this open cloud-based architecture, which I think will benefit not just the forecasting, but the observation systems going into the models.
And one more time, touch on what you would define as the milestones that will reflect our progress towards closing the gap with the Europeans.
So the first initial milestones of success would just be how many external stakeholders are actually using the code. So we would want to monitor how many downloads, what's the user interest, and after that we would hope that we would start to see contributions and improvements coming back. But the initial steps are just getting the external stakeholders engaged in the program.
And Dr. Mass, you're not exempt from these kind of questions either. And I asked this, and I think I know the answer, but I'm going to ask: does the broader weather research community support EPIC?
I think the answer is clearly yes. but we want EPIC to be something that does serve the entire community. That's crucial.
Thank you, Doctor. And with that, I yield back, Mr. Chairman.
Great. Thank you very much. Thank you to the witnesses for being here today. We all appreciate your attendance. The ability to forecast hurricane tracks has greatly improved since the 1960s. Forecasting hurricane intensity has also improved, but less so than the track forecasts. In fact, in 2017, Congressional Research Service reported on forecasting hurricanes found that the biggest challenge facing the National Hurricane Center is how to improve the ability to predict hurricane intensity. Being able to better predict how strong a hurricane will become, as well as when and where it will peak in intensity, is key for the district I represent along the west coast of Florida, which, as you know, is incredibly vulnerable to hurricanes year in and year out. So, Dr. Jacobs, given how costly hurricanes are to the United States, and in particular to Florida, how will EPIC improve hurricane intensity prediction, if it will?
My expectation is that it will. The focus primarily for hurricane intensity is largely centered around two things: two-way coupled modeling with an emphasis on sea surface temperature, because that's essentially the fuel, and the physics in the model. So there's a deficiency in the model physics that needs a lot of research and improvement. EPIC will essentially be the external sandbox where stakeholders can test their improvements to both the physics as well as the two-way coupling of the models. And then additionally, new observations, new observing systems. So there's a lot of new observing systems coming online, not necessarily NOAA assets, but industry assets and even academic devices that we don't have the internal bandwidth to test the impact of those obs in our system, but we can test the impact of those observing systems in the proposed EPIC sandbox.
Great. Would any of the other witnesses care to comment on how EPIC will improve hurricane prediction? Dr. Neely?
Thank you, Mr. Christ. I think one of the critical ways in which EPIC can improve hurricane forecasting is by marriage of the unified forecast system with next generation data assimilation techniques, particularly the types of technologies that are being developed in Dr. Arlini's group. There has been some numerous scientific evidence that data assimilation, taking the observations that Acting Administrator Jacobs mentioned and using them to initialize the model, can be one of the most important aspects of getting the hurricane forecast right. EPIC, if it crafted correctly, is the cauldron in which entices all of these scientific capabilities to come together and be married to improve our weather forecasting capabilities.
Great. Thank you very much. Any others? Yes.
Let me tag along to this response. So there's multiple evidence showing that if we're looking at the quality of the forecasting, the definition of the initial conditions and the actual model are equally important, and data assimilation is handling the initial conditions for the model. So we're actually blending together observation and a previous model forecast to actually optimize these initial conditions with, due to nature, the chaotic nature of the atmosphere are propagating and amplifying in the forecast. So it's actually a critical component of forecast accuracy.
Great, thank you. I wanted to ask, I'm running out of time, I wanted to ask one additional question, if I might. In addition to weather forecasting, NOAA is also responsible for researching and modeling other types of environmental concerns, such as red tide and algae bloom, which, as you know, is of great interest in the Sunshine State. Dr. Jacobs, can you discuss how EPIC will help improve forecasting for red tide and other harmful algae blooms?
So, as I was explaining earlier, a lot of these harmful algal bloom models depend on the atmospheric model forecast of precipitation and runoff to determine when there will be triggers. Ultimately, we are going to put in all of these secondary